Today we're going to do 12.5 scatter plots and lines of best fit. All right, a scatter plot is a graph that shows a relationship between two data sets. The two sets of data are graphed as ordered pairs in a coordinate plane. And here are some examples of scatter plots. What you'll notice is, unlike before, these relationships don't form neat little lines, which is why they're called scatter plots, because the dots are scattered across the graph. What's important to know, though, is the relationships, and there are three different types of relationships. The first is a positive relationship. And a positive relationship occurs when, as the x-axis increases, going from left to right, the y-axis also increases. If we were to draw a line, it would have a positive slope. And because it would have a positive slope, that makes it a positive relationship. This one here has a negative relationship. It would have a negative slope. As x increases as we go across the x-axis, the y values are decreasing, thus creating that negative relationship. And the last one here is one that has no relationship. The points show no pattern. Why relationships are important is they help us to make predictions about future ordered pairs in that relationship or in that data set. The last thing we'll do today is a line of best fit, and it's a line drawn on a scatter plot close to most of the data points that is used for estimation. And that's what we'll use specifically to make predictions. All right, first order of business here is we're going to look at these three graphs. We're going to tell whether the data shows a positive, a negative, or no relationship. So let's take a look at number one. If you see the points of the scatter plot, they appear to be trending in an upward direction. In other words, as x increases, the y value is increasing, forcing the scatter plot to go in an upward direction. That is a positive relationship. Number two, as we look at this scatter plot, the dots don't appear to show any relationship at all. Some are when x increases, y is increasing, and some is the opposite, whereas x is increasing, y is decreasing. They're kind of all over the place. When that occurs, there is no relationship. And number three, again here, if you look at the graph, they're kind of trending in a downward direction. In other words, as x is increasing, y is decreasing. This is an example of a negative relationship. All right, next problem here. We are going to be reading the graph. The scatter plot shows the amounts of fat in grams and the numbers of calories in 12 different restaurant sandwiches. Again, notice it's a scatter plot because they don't form a nice, neat little line. And we're going to answer some questions based off of this graph. First one says, how many calories are in a sandwich that contains 17 grams of fat? So what we want to do is we want to read the graph, find about where 17 grams would be, which is right about here, and look up, and there's a point there at 400 calories, so that would be our answer to letter A. B, how many grams of fat are in a sandwich that contains 600 calories? So we're going to go to our graph, go to 600, and find out how many grams it has. There we go. That would be 30 grams of fat. And then part C, describe the relationship. This appears again to be going in an upward direction. In other words, as x is increasing, y is increasing. I would say this has a positive relationship. All right, finding a line of fit. The table shows the weekly sales of a DVD and the number of weeks since its release. Make a scatter plot of the data and draw a line of best fit. What I would like you to do is to go ahead and pause the video, and I'd like you to create your scatter plot. Weeks is the x-axis and sales is the y-axis. Please remember to label your axes and spread this out in an appropriate way so that your graph is legible. So go ahead and pause the video, and then when we come back, we'll compare it and we'll work on drawing a line of fit. Okay, so your graph should look something like this with all of the points plotted in there. All right, so now we've got to draw a line of best fit. Now to draw a line of best fit, what you do is first you have to recognize the relationship in the data. And you can see that my data here is trending in a negative direction. The rule of thumb for a line of best fit is to draw a line that is basically in between all the points. It'll go through a couple of them, but there should be approximately the same number of points above and below the line that you draw. So I'm going to go ahead and draw this one, and I'm going to start it here. It looks like maybe we should use 20 as our y-intercept. As I kind of play with it, and you can do this with a ruler, we want to try to get it so that about the same number of points are above and below the line. And it's pretty close. I have 3 above and 3 below. It does go through 2 of those points there. It's kind of like almost a perfect indicator that we got this one right. So there's going to be my line of best fit. Go ahead and pause the video so you can draw your line in the same spot as mine. Okay, now it's asking us to write an equation for the line of best fit. And when you write an equation in algebra, it's going to be in slope-intercept form. So we are going to try to get it into y equals mx plus b. First thing I need to do is I need to find the slope. What I look for is were there any points where my line of best fit went through the data, and we got lucky here. It went through 2 of them, so those are the 2 that I'm going to use. I'm going to use these 2 points. That's what it went through. Again, to find slope, it's y2 minus y1, so that would be 8 minus 10. And x2 minus x1, which is 6 minus 5. So my slope is going to be negative 2 over 1, or just simply negative 2. And that's going to be my slope. The y-intercept, my line of best fit went through the y-axis at 20, so I will use that in my equation. So we'll do y equals negative 2x plus 20. Interpreting the slope of the line of best fit, to interpret, we want to say what that means in real life. Again, remember when you're doing slope, it's the y-axis over the x-axis, so the negative 2 has to have a label from y. So we're going to say that the sales are decreasing because it's negative. $2 million per, and it's 1 week. Again, it's essentially you're writing a unit rate when you interpret. All right, last part of this question asks us to predict the sales for week 9. Whenever you're asked to do a prediction, you want to use your equation for your line of best fit. So I'm going to use my y equals negative 2x plus 20. And week 9, weeks is our x-axis, so it's going to be y equals negative 2 times 9 plus 20. Plug that into our calculators, and we are going to get $2 million. And make sure you do label it million, because that's what it's about. If you just do $2, it obviously would be a wrong answer, because 2 million and $2 are 2 completely different things. All right, last problem. The table shows the money you owe to pay off a credit card bill over 5 months. And our first part here is to make a scatter plot of the data. I'd like you to go ahead and pause the video, label your X and Y axis, and plot those 5 points into your graph. Okay, it should look something like this. Again, our money owed was our y-axis, and our number of months was our x-axis. And there's your points. I went up by 200 on my y, so it fit nice, and 1 month each for the axis. Okay, now we have to draw our line of best fit. Looking at the pattern here, we definitely have another negative relationship. So if I kind of try to extend it, it looks like maybe we want to do our y-axis on 1,400. And kind of draw our line and kind of play with it a little bit and try to see if we can get a same number above and below. Oops. I think that looks pretty good. So that would be our line of best fit. Again, it's got the same number above and below. All right, part C says to write an equation for the line of fit. I would like you to go ahead and write your equation. I'm going to let you pause the video and do that. It's y equals mx plus b. And then I'd like you to do part D, predict the amount of money you would owe in 6 months. So go ahead and pause the video, do that, and when you come back, you can check your work. All right, my line of best fit went through the first 2 points up here, the 1, 1,200 and 2, 1,000. So those are the points that I used to find my slope, and my slope is negative 200. Again, going back to the graph, the y-intercept was $1,400. So there's my equation, y equals negative 200x plus 1,400. And then for D, predicting the amount of money for 6 months. Again, I substitute 6 into my equation. Always use your equation to predict. And we get that you would owe approximately $200 after 6 months. As you get into Algebra 2, the graphing calculator will do lines of best fit for you and give you those equations of those lines of best fit. And that's something that you'll do in Algebra 2. They'll teach you that. Hopefully they do it before you take your Keystone exam, because that certainly would help you a lot for those type of problems. So that's it for today. Go ahead and work on the practice problems. I know you don't have graph paper at home. Maybe some of you do. But do the best you can in creating your scatter plots, and use a ruler for your line of best fit. It's the best way to go about it. All right, I'll talk to you soon. Take care.